Identify between permutations and combinations. Combinations is only concerned with the unique combinations and not with the rearrangement of the same combination. Say we have 5 items A, B, C, D, and E, and say we need to select any 2 items out of this 5. So the combinations would be AB, AC, DE, BC, and so on. Right? So these are the unique combinations. Now, permutations is concerned with the unique combinations and also with the possible arrangements of the same combination. So for the same question, uh, we will also have to count B comma A, C comma A, and so on. So yes, we are concerned with the unique combinations, which are this, but we are also concerned with in how many ways we can arrange each combination, each unique combination, right? So A, B, we can arrange it in 2 ways, A, B or B, A, and so on. So that's permutations for you. Now, the main source of confusion that students have in permutations and combinations is how to identify if a question is based on combinations or permutations. Because what happens is students have a mindset of, okay, this question is combinations, then I'll apply this formula. Oh, this question is based on permutations, then I'll apply the permutations formula. So that's that's what creates a bit of a confusion because we're trying to fit in a formula to a question rather than understanding the question. So we can avoid this confusion by not using the formula for permutation altogether. So this is how we'll do it. Um, Take example 1. In how many ways can a group of 3 candidates be selected out of 10 candidates? This is a simple question of combinations. All we have to do is count the unique combinations of 3 candidates, right? So if the candidates are A, B, C, D, E, and so on, then A, B, and C could be the 3 candidates selected, or it could be B, C, E, the 3 candidates selected, right? So these are all unique combinations. How many of them can we find? It is 10C3, which is equal to 10 factorial divided by 10 minus 3 factorial times 3 factorial. And whatever the answer is. Now, the same question in a slightly different way. In how many ways can a group of 3 candidates be selected out of 10 candidates for the post of a manager, a vice president, and a director? In this case, just selecting any 3 candidates will not be enough. So, what I'm saying is just counting the unique combinations of 3 candidates, which is 10C3, is not enough. Because say we have selected these 3 candidates, A, B, and C, out of the 10. Now, for the post of manager, vice president, and director, we could have A, B, or C, right, where A is the manager, B is selected for vice president, and C is selected for the director role. But it could also be that A is selected for manager role, C is selected for the vice president, B is selected for the director, and so on. So we see that there are 6 ways in which uh, the same 3 candidates can fill in the 3 roles. So this question is um, also asking you to take into account the arrangement of each combination of 3 candidates selected. So each of the unique combination of 3 candidates can be arranged in 3 factorial ways, which is 6 ways. How do we do that? Say we have these 3 roles to fill: manager, vice president, and director. Now for the first role, we have 3 options, any of the 3 candidates. So it's 3. Now we are left with 2 candidates, and for the second role, so any of the 2 candidates can fill in. Now for the third role, the remaining candidate will fill in. So this is 3 times 2 times 1 is 6, which is 3 factorial. And so this is true for all the unique combination of three candidates, right? So this calls for counting unique combinations, which is 10C3, right? And counting all possible arrangements of each of those unique combinations, which is 3 factorial. So we found 3 factorial for the candidate selected A, B, and C. Similarly, we'll find the same number of arrangements for any group of 3 candidates, right? So the total number of ways in which 3 candidates can be selected for the post of manager, vice president, and the director is 10C3 times 3 factorial. This is your permutations. So notice that we are not using the formula for permutations. We're not trying to fit in anything. Now, the only way, so how we are identifying between permutations and combinations is understanding whether the question is asking for arrangement of the selected group of items. If that is the case, then we do it this way, or if the arrangement is not to be taken into account, then the answer would be only this 10C3. That's